bad run. You can still use Vim on Windows. And that's actually what I'm going to be doing. What's my GitHub? You'll see later. God damn it. Oh no, Vim. Yeah. I mean, the problem with using like Git is that you need a command line text editor sometimes, or you just need it. So I'm not going to teach Vim, but I need to like tell people how to like exit Vim, right? Because if you want to use Git on the command line. So that's like it. How long have I been a dev for? A couple of years now. Not too long. I hit 3 years at Amazon like next week, I think. So there's that. Then, you know, when I was in college, I did like some stuff. You know, you guys are talking about these like Git UIs, and I've never used any of them, so I don't know. I've only ever used Git on the command line, so I have no idea. Eh, 85 is slow. I have time for like one more game. You guys can hear me, right? I'm not talking to myself. Okay, great. Fuck. I work at AWS. I work on the AWS SageMaker product. When am I starting? On the hour. Still have 6 minutes. I'm just playing Minesweeper until then. What are we doing today? I have a summary on the Discord. Should be the previous post. If you want a programming job that's math heavy, go into games. That's like the only thing, really. Machine learning, well, I'm a little qualified to talk about this since I actually do work on machine learning stuff. Machine learning is only math heavy if you're actually developing like a machine learning framework. Like if you're actually working on TensorFlow or PyTorch or MXNet or something like that. If you're just doing like building models, it's really not that math heavy. Like if you're building models, all you're really doing is tweaking like parameters a little bit. It's just like, I don't know. It's not for me. And if you're actually doing like, if you're trying to like build a new machine learning model, you're not really a software developer, you're a scientist. You know, they have different concerns than like us engineers. And even like building models, like it's not really like programming, really. I don't know. It's difficult to explain to people who don't really understand. You need I need to like define a lot of things to make it like more concrete, I guess. I'm not really good at explaining it. Yeah, machine learning is just so whatever to me, honestly. Fuck it now. Alright, am I L4? No, I'm L5. I mean, if you're at Amazon for 3 years and you're still in L4, you've got problems, man. View, present, notes, pointer. If you want to be a scientist depth, then you need a PhD. You just need a PhD. Am I comfortable talking about my salary? Yeah. When I was first hired, my starting salary is 120,000, and I got 80 shares of Amazon vesting over 4 years. When I got my promotion, my starting salary got bumped up to 168, and I got a few more shares. I don't remember exactly how much. And now every year, like basically, every year after performance review, you get some amount of shares too. Yeah, I think everybody should I think you should just be able to share your salaries. Like, it shouldn't be something you're trying to hide or ashamed of. It helps everybody to just know what everybody else makes. Okay, so it is 12 noon, and we should get started. So, good morning, ladies and gentlemen. Welcome to the second session of HealthyGamer's Intro to Full Stack Development workshop. So last time we talked a little bit about like networking and like basics of the cloud. Today we're going to talk about setting up a developer environment. So I'm assuming that most people here are just like completely brand new to programming. Like you might know like you know that text is code, but you've never like interacted with a terminal before. So I'm going to show you like how to become Hacker Man. We're going to talk about version control, why you need it. I'm going to set up a GitHub repository, and we're going to do things. And the first thing that we're actually going to code as part of this workshop is our continuous integration and deployment pipeline using infrastructure as code. Okay, so terminals. You've all seen, if you've seen the people typing at terminals and they become Hacker Man, right? It's terminals are really mysterious because people don't really use them a lot. People mostly use graphical user interfaces, but they're really not that scary. First thing though is that we are going to be using a Unix. I'm going to assume everybody's going to be using a Unix environment for this workshop. If you have a MacBook or like a Mac, then that's great. That's like, there's a reason why all the Silicon Valley software companies, tech companies give you MacBooks as default, right? And it's just like, if you have the money, just get a MacBook. If you don't have a MacBook, you have like a Windows machine, you can dual boot Windows and Unix. Like, you can install a Unix operating system onto your hard drive, and you could boot into either Windows, either or. It's really not that complicated. There are guides on how to do it. I did it before when I was in like high school. It's really simple. Otherwise, if you don't want to care about that, you can just install this thing called Windows Subsystem for Linux and Windows Terminal. What shit? God. Yeah, you can just Google search these and install it. I honestly think dual booting Unix is simpler than installing Windows WSL, but that's just me. Why not command? Because that's not a Unix environment, and things are just not built for Windows like that. Unix equals Linux? Not necessarily. So Unix refers to the original Unix operating system created in the 60s at Bell Laboratories, of which the BSD and Mac OS are descendants of. Linux is also a descendant of Unix, but they're not the same thing at all. So Linux and Unix are not the same thing. Mac OS is Unix, BSD is Unix, Linux is Unix, but they are not the same thing. Okay, so text editors. During the course of this workshop, I'm going to have to be writing code, and my normal preference for writing code is actually Vim, which is a terminal text editor. You actually use terminal to edit text. My Vim configuration is on GitHub if you're interested. However, if you're completely brand new, you don't know what Vim is, you've just started programming, my recommendation is do not use Vim. Do not start using Vim. Okay, Vim is complicated. Don't. So instead, I would recommend that you use Visual Studio Code.
instead. Again, you could just Google search this, and it should be the first thing. It's not Visual Studio, it's Visual Studio Code. Okay, there is a difference. Okay, I don't recommend trying to learn Vim and programming at the same time. This is too much. Once you get comfortable and you know, as you watch me, you like what you see, then you might go back and try it out, but don't start off with it. Unfortunately, Git requires a command line text editor such as Vim, so because of that, I do need to go over the very, very basics of it. That's all I'm gonna do. I'm not gonna talk about like, you know, like advanced Vim things. Like, I don't even use a lot of advanced Vim things, but like, so I need to go over like how to exit Vim, which is a big theme. Alternatively, you can use a graphical interface for Git. I have no recommendations for any of these because I have never used one. That's just it. What about Nano? I don't like, okay, if you want to use Nano, go ahead, man. I don't care. Again, you can choose any text editor that you want. I don't care. Otherwise, just use Visual Studio Code. Can't you use a terminal for Git? Yes, you can use a terminal for Git, but that means you need to know Vim. Git bash is a terminal. It's the same thing. Great. So let's just open up the terminal. So you know, a terminal, so, like when you use Windows and you open up like the Finder, this is just a way of interacting with the operating system, right? You click around, like the operating system doesn't know that you're inside the documents folder. Like, it doesn't care, okay? It doesn't know about this. And it's the same thing for the terminal, right? So the first thing is like listing is what are the objects inside your directory. That's ls, and ls gives you everything inside it. If you do cd with no parameters at all, that takes you to the home directory, which is different for other people. And if you want to know where you are, you type pwd. That tells you where you are. ls again. Okay, so like, and then cd, and then with a directory name takes you inside the changes your directory. cd stands for change directory. You want to create a new directory, you type make directory, and we can go inside this new directory. If you want to create a brand new file, you do touch, I don't know, I guess we do that. And this is an empty file. You want to look at what's inside a file, you do cat, and it's an empty file, so there's nothing in it. Link to GitHub, please be patient. And you know, there's more, but that's really the basics. What does ls stands for? I think it's called list something. I'm not exactly sure what the s is, but it's like list something. Yeah. It's like, so how do I download stuff with the terminal? There's two different ways. One is called a package manager, which they manage packages. I don't know, the name should be pretty self-explanatory. They manage packages. Every Unix distribution has a different. For example, the Ubuntu Debian distribution uses apt. Like if you use CentOS or RHEL or whatever, that's like yum, and they're all different. macOS doesn't come with one, but you should just Google search Homebrew. Just Google search and install Homebrew. That's basically the default for Mac. Another way is curl or wget, which are command line network clients. We use them to do networking stuff with it. Here we go. So like you can do curl https google.com, and Google will give you its webpage, something like that. But you can also use this for like downloading files and things. So utilities we need to install for today. We need to install Node and npm. Oh god, I had a typo. God damn it. That's embarrassing. And we have to install the AWS CLI, which does AWS stuff, and we have to install these two things. Okay. So first things first, if you Google search how to install Node, you'll come across this page, github.com/node source/distributions, and you just follow it. You just click whatever one you want. I have Ubuntu. and Node.js 14. You just copy paste this in, and it'll install it for you. Yeah. Okay. It's not very difficult. So like here I can sudo. It does the thing. Hacker bans. It failed. Okay, well, if it fails, then learning how to fix things is also learning how to fix things is something you need to know. No module named apt package. Ubuntu 18. And it says, oh, I need to install this thing. Okay, great. So I'll just do that. I've already installed Node, so I don't really care. Why not Python? We'll talk about Python. But the short answer is I fucking hate Python. Yep. Great. And now to install the AWS CLI, again, you just Google search it and you'll come to, well, not this page. You'll come to this page, installing the AWS CLI. And again, you just, you just find the thing and you just copy paste it. It's not hard. Don't decolon me. Oh, I have a big rant on Python we will get to next session. Oh, it's gonna be great. I don't want to get into it now. It's a big giant rant. Okay. Again, so like, yeah. So for the AWS CLI, again, you just Google search it. Okay. And just say, oh, we curl a zip file. Great. And then you just unzip it and then you install it. Like, terminals are not magic. They're not very difficult. They're pretty self-explanatory. And last but not least, we need the TypeScript compiler and we need the AWS Cloud Development Kit. So these two are not downloaded through your normal package manager. They're downloaded through NPM. So when you install Node, you also install NPM, and notice the Node package manager. It downloads Node modules. And to do that, you do sudo npm install -g TypeScript and CDK. And it'll just go. And this should not fail. Please get into it now. Can't do that. It's going to take too long. We have a lot to cover today. Great. So yeah, it's not hard. You should go back and rewatch it if you want to, but like, it should be. I hope it's self-explanatory. I hope it's self-explanatory. You just Google search it, you find, and then they'll just give you some commands, and you just run the commands. You just copy paste the commands into your terminal. So, the next thing we got to do, we're going to talk about version control. And if you don't know who Linus Torvalds is, Linus is the man who created the Linux kernel. He also created the Git version control system. And these are not my words. This is the creator regarding his own creation. So, it gives you a little sense of feedback, why would he say this about it? Why is Git shit? Oh, we'll talk about that too. So why use version control system? Give me 1 second, please. Where's mine? VCS solves two different problems, and the first and probably the most important is how do multiple people work on a single code base without overwriting each other? Like if you have like a Dropbox and you're editing a file, you can't have another person editing the same file at the same time. At least you couldn't when I first started using it. I don't know about it now, right? But like if you change a file and you save a file, and another person is working on the same file at the same time, how does that person get your changes, and right? Because how do you synchronize that? And there's also the 5 W's of writing code. Who made the change? You're looking at a piece of code in your code base, and you think to yourself, what the fuck is, who the hell committed this incredible piece of shit into my code base? And you take a look, and it's always fucking you. Okay? It's always you. It's always you. But, you know, you need to be sure who made the change. What else did they do? Like this changes are not made in isolation usually. What else did they do? When did they do it? Like, okay, like I know it's me, but like when the hell was this? Like in what state of mind was I when I made this stupid change? Where else did they make it? Like this is kind of like what, but you know, where, like I need to know at a glance where exactly did this change happen so I can like undo it, because it's always you and you need to fix it, right? And also probably the most important is, why did they do this? Why did you, it's always you, why did you do this to yourself? Okay? So the way I'm gonna only use Git terminology. Other version control systems might have different terms or whatever, but the basic layout is the same. You write your code and you commit your code. You turn your change into what's called a commit. And the version control system takes your commit and builds on top of previous commits to form your change history, your commit history, your Git history, you know. Let's see. And one of the features about version control that lets people collaborate effectively is that history can be diverted into branches. So you have like a linear history, but at this history, at some point, anybody can just take a change and they can fork it and create a branch. And eventually, when you're done writing your branch, you can take your branch and then you can push it back onto your linear history. Yeah. So Git. Somebody asked in chat earlier, why is Git shit? And I don't know if Linus had what I had in mind, but when I think of why Git is shit, it's because of the user interface. Like, there are so many commands in Git. It's just like, it's ridiculous. Git has the worst user experience, like, in anything. And like, don't even bother trying to memorize all this. I'm just gonna be using these out of memory, and like, you know, as I'm using them, you could like see like, oh, how I do it. And there's so many things that you need for Git. It's ridiculous. So that's why, like, if you really want to, like, you should probably just use a graphical interface. But I've never used one. I did it the hard way. I just memorized all this shit. Okay. So we go to GitHub, and GitHub has actually no affiliation with Git itself. Git is not a trademark name, I suppose. So GitHub, just do it. GitHub is a service that stores Git repositories for you so that other people can see them and other people can collaborate with you on your projects. So like, you go to create a new repository, and we're going to create HealthyGamer Workshop is available. I'm going to make it public. Choose a license. And because it's public, this is just an aside, because it's public, you really should add a license, which is basically, you know, how do people, what restrictions are you going to add when you create your open source code? And I took a look, and I chose BSD, but like MIT is very popular, GPL is very popular. You know, it's really up to you. You really should do your research before choosing the license that you want to use. So I'm going to use BSD. I create a repository. And great. So, open the terminal again. Let me just go to cd code, make dir HealthyGamer Workshop. Go over licenses, please. No, I can't do that. I'm not a lawyer. Okay. These are legal documents. Okay. These are legal documents. I'm not a lawyer. I can't like go over. So like BSD very simply just says that you're allowed to do whatever you want with the software as long as you give me give me credit for it. That's fine. And I also give you no warrant, and you use this code without any warranty, basically. That's basically it. Oh, also here's my GitHub. You can search my vimrc if you want. So we go to CD HealthyGamer Workshop that I've created. Is the terminal okay? Is it too small? I can make it bigger. Okay, nobody's complaining, so I guess it's fine. So the first thing that you do is git init. Initialize empty Git repository. Great. Now the second thing we do is, oh wait. Actually no, sorry. Forget that. rm deletes rm-r deletes a directory. So what we're going to do is git clone https github.com/healthygamerworkshop.git. You can see that, you know, this is the URL to my repository. So git clone, and this creates HealthyGamer Workshop, and it adds, and I have my license. This license is the same file I have here. So like, you know, you could compare, but it is the same file. And basically what git clone does is it takes a repository from a remote location, so like GitHub, like a server or whatever, and it copies it to your local directory. Cool. So, and that's it. So now git branch says I'm working on the master branch, and I'm working on the master branch. So now we have a repository. What's the first thing that we're going to do? And I think the first thing that we should do is we should go over infrastructure as code. We'll talk about YAML. So working backwards, what is infrastructure as code and why do we need it? If you guys watched the previous session, you saw that I went to the AWS S3 website and I clicked some buttons and I typed some things in and I created a bucket manually through the website. The reason that is okay if you're doing like one thing, maybe one or maybe two things. The problem is when you're building a real application, you don't have one or two resources, you have dozens, maybe hundreds of resources. Trying to do that by hand is impossible. You're going to mess up somewhere, okay? You're just going to mess up trying to do this. So first of all, like, how do you even keep hundreds of things in your head? You can't do it. And maybe you can do it, but you're not going to work on a team where everybody in the team can do it. So first thing is I need a record of every single thing that goes into my application, right? For just like being able to know what's in it in case we need to change it later, and also because like I need to see like what my application is made of, so I could like have an estimate of how I'm getting billed, for example. I need to maintain a history of infrastructure changes, because this is most important for like if you make a change and you mess it up, how do you know how to go back to a good location? So it's extremely, like, when people mess up, it's not an if, it's a when people mess up. You need to be able to go back to a good location. a good revision. I need to see how my infrastructure connects together. So like, again, you saw in the previous session when I created my S3 bucket, I created it and then I did some magic in a different website, the Route 53 website, to connect my bucket together. But how do I know to do that? Like, how do I know that that connection exists? All right, like with that, like, there's nothing telling me that in here that there's a connection to this other completely different thing. And going back to this maintaining a record of everything, if I have applications are built on, you know, large sets of resources, I want to be able to get that entire infrastructure up and running as a single unit without making mistakes. Without mistakes. This is so important because if you're a human, if you trust this with a human, they're going to make a mistake. Okay, which is why I need to be hands-off in my deployment. I cannot let a human person interact with this at all because they're going to mess it up. You are going to mess it up, okay? This is just a fact of engineering, is that humans make mistakes. And so we want to be as hands-off as possible, almost always. So, and the solution to this is something called infrastructure as code, okay? It's really, as it sounds like, you just write up your infrastructure as like a text file, and then you give it to, you know, one of these solutions, and they'll take your code and they'll just build it for you, right? You have your cloud specific ones like this crap. You have your things that, one of their marketing things is that, oh, you could take your Terraform and you could deploy it to any cloud, and that's like half true, because like you still need like AWS specific things or like GCP specific things inside your Terraform. So, you know, it's fine. There are several others. They're all pretty similar to each other. So we're going to use AWS CloudFormation because, you know, I've never actually used Terraform. I don't really know how to use it, but it's fine. CloudFormation defines your resources in either YAML or JSON. And if you don't know what YAML is, it's basically JSON. Just think it's JSON. Okay. This fucking sucks. I hate YAML so fucking much, all right? I genuinely cannot overstate how much this sucks, okay? Because like, imagine like you have hundreds of resources inside this giant YAML file, and they have to like talk to each other, and you have to know how it is. Like it's spaghetti, okay? It's awful. It's terrible. And it's not like AWS is the only one, all right? Like oh, AWS sucks, you should use it. No. They're all the same, all right? They all use YAML for this shit. Okay? Everybody is terrible. Everybody sucks. YAML is the worst thing, the worst possible way to define something like this. It's so bad trying to manage these giant templates with like hundreds of resources, and you gotta like talk to each other. And like the worst thing is like when you're doing like IAC stuff, you gotta have like conditions, like if statements inside your JSON. It's so awful. Like, oh, I missed a space somewhere, so now the if is not attached to the thing I want, it's attached to to another thing, and it's like, I want to kill myself. Okay, it's so terrible. I hate it. Uncensored honesty, you bet your ass. You should create a new standard. I don't need to. Here's an idea. We should use an actual programming language to generate YAML. Wow, we get all the benefits of programming language, and that's exactly what AWS CDK is. You know, we installed it earlier. That's what AWS CDK is. It's available in whatever languages. I already said I hate Python, and I'm not using Java for this, so we're going to use TypeScript. Okay, you can use CDK to generate either CloudFormation or Terraform templates. You know, if you want to use Terraform, fine, but we're going to be generating CloudFormation. Okay. Where the hell is it? Okay, here it is. So in our terminal, we're going to make dir CDK. We're going to do CD CDK, and we're going to do CDK init language TypeScript, and that's it. And now we just wait for this. This takes you, this will take some time. Oh god damn it! I forgot to turn it off.
Edward.
Oh god, I told myself I was going to turn this off for this week. God fucking damn it, I forgot. Oh god, I'm so, oh my god, how could I forget to do this? Ugh, I'm so dumb. Forgot, I said I was going to do this, I forgot to turn it off. Not Alexa though? You're right. And if you were here last session, you would know I don't get Alexas for free. I did, however, get this Google Home for free. There was a promotion if you had Spotify Premium to get a Google Home for free, and I signed up for this shit. Alright. LS. Okay. So, CDK init creates a whole bunch of things. So, tree I node modules. As a note, you never, ever, ever want to look inside node modules or packagelog.json. Don't ever look inside these if you want to keep your sanity. Just pretend they don't exist, all right? They don't exist. They're magic. We see that the CDK has created a binary folder, a library folder, and some tests that we don't give a shit about. We don't care about, but it's pretty simple. Yeah, don't look at their sizes. Don't look inside node modules or package lock. You will lose your sanity. Don't. I did it once. It wasn't good. Okay. So we have these things. So the question is, what are we going to make? And I suggest that we're going to start using CI/CD. And if you play Path of Exile, you know that CI stands for Chaos Inoculation. And that's not exactly what CI stands for in software engineering, but it's actually a good way to think about it, really. Like, you inject a little bit of pain to make your developer experience, to inoculate your developer experience against unwanted behaviors. So CI doesn't stand for chaos inoculation, it stands for continuous integration, which means every code change, every time you make a commit and you push it to remote, a server should take your changes and compiles it and tests it automatically without you doing anything. Great. And CD stands for continuous deployment. Some people call it delivery. I usually use deployment, continuous deployment. Every code change, again, should be made customer-facing automatically without manual intervention. This phrase is usually called deploy to production or deploy to prod. Yeah, by making customer facing, we mean that you make a change to change a bug or change the font size or whatever, right? As soon as you push this commit, you lift your hands, that change should be an external customer should be able to see that change without you having to do anything at all. Okay. And when you mess up, because again, it's not an if you mess up, it's when you mess up. Ideally, your mess ups should be caught by your integration tests before they get deployed. Okay? That's if tests are insufficient, and tests are always insufficient, you should be able to revert your changes, roll back your changes to the last known previously good revision of your change. This is the heart of continuous deployment. And as for this case, a good saying is that tests only show the tests only show the presence of bugs, never their absence. Your tests only show that maybe you have a bug, but just because you have tests doesn't mean that your code is entirely bug free. Tests are always insufficient. Deployments to prod should never be automatic. I disagree. To that, you don't need manual confirmations as long as you have testing and alarms, basically. CI/CD together are usually not done separately. They're done together in a single pipeline. Okay, so you start with your code repository. Is it okay if I don't follow along? Yeah, go ahead. There's a I probably saw that error. You should just go back and watch it. You start with your source code repository, so like your GitHub repository, and something takes your repository, it compiles it, and does some basic testing on it. And then you deploy to your testing stage, if you have a testing stage, and it does some more tests on it. And if these tests pass, then you deploy it to production. And you run more tests, not to like test against production, but just like as a sanity check to make sure that something didn't go wrong during these steps, basically. As a side note, we are not going to have a beta testing stage because I'm cheap. And I doubt most people here will either. However, if you work at a company and they don't have a beta stage, you need to question why. Because like somebody said in chat, deployments to prod should never be automatic. There needs to be some sort of manual confirm. I disagree with the manual confirmation part, but there does need to be some sort of confirmation part. You need to make sure that your change is validated by something end to end, from start to finish, by something. And if your business doesn't have this, then something's fishy with this business. That works fine until your deployment successfully buglessly does the wrong thing with no hiccups and no errors. Yeah. I don't know what you're referring to, but yeah. As a side note, what is the difference between these tests? The answer is there's no real firm boundary between test types at all. The commonly accepted phrases is that unit tests look at a small unit of functionality, but the question is like, what's a unit? And the answer is there's no answer. Like, a unit is whatever you want it to be, really. Like for example, Jonathan Blow, the game designer, engineer, he made Braid and The Witness, and he streams on Twitch, by the way. His streams are always very insightful, for me personally. He basically thinks there's no difference between unit tests and integration tests at all. And he basically thinks that unit tests are worthless because it's just too high effort for very low reward. And I think his view is a little extreme, but overall I do agree with it. I think unit tests are kind of too much work for not enough gain. However, you really do need functional tests. A functional test tests an entire product end to end. For example, if you have a website, you write your website in code, and your unit test might look at the code to do what it wants. However, a functional test is something like you open up your browser and you click buttons, and you make sure like all the buttons appear, and like all your forms work properly, and like if you do this thing, it throws an error successfully, like things like that. Testing things end to end. If you guys ever played Factorio, the devs on Factorio have some YouTube videos about their functional tests, about them basically running a game, the entire game, end to end, like testing little like functionality of that, and it's actually really cool. So you can look that up on YouTube. Okay, so like CI/CD solutions. There's a lot of different CI/CD stuff, and if you came to this workshop and you were hoping that I was going to talk about Jenkins or Spinnaker or whatever, I'm sorry to disappoint you, but we're not going to be using any of those. And the reason for that is money. It's always about money, all right? Everything's about money. And it costs money because open source CI/CD libraries require servers, and that costs money. And if you don't know why this costs money, you should go back and watch this first session where we did the calculator, the AWS calculator stuff, and we saw like servers cost a lot of fucking money, all right? Of course, serverless approaches to CI/CD do exist, even for these open source ones. However, doing this requires packaging CI/CD them inside a container, which means learning Docker, basically. Docker is very complicated, and it would be an entire session just on its own. And while I would like to do it, it's just a lot of work, and I don't really have that much time. We have a lot of things to cover in this workshop. And then, once you have this container, you can run them serverlessly using something like Fargate or Cloud Run. It's fine. DM me if you want to see a session on Docker just to gauge interest. Like, I'm not planning on doing it, but if you do want to see it, go ahead. Tell me. So because of that, because of all this crap, we're going to be using some AWS products instead. They're all serverless. That means they're mostly cheap. I'm also lazy and I've got a lot of work, so these AWS products are pretty simple to set up, but they do lack features heavily. Yeah, especially like Code Pipeline. Code Pipeline is just like so bad. I swear to God, I'm not a shill. I swear to God, I'm not being paid to advertise AWS, even though I do work for the company, all right? I swear I'm not a shill, all right? It's just because I'm lazy. And I've already said that Code Pipeline is shit, so there's that. Okay, so we're done with this for now. And now we're going to open this. Vim. Hurry up. All right. Give me 1 second, actually. You found Docker very powerful? It is powerful. It's just a lot of work. So, again, I'm just lazy. So, when you use CDK init, it adds some dummy tests for you. It adds some dummy code for you. The code that defines your stack goes here. Great. That's just peachy. The first thing we need to do is we need to get the actual dependencies that we want. And for us, so we need a few of them. Oops. We need AWS CodeBuild. AYP, CFC, code pipeline, code pipeline actions. We need IAM. Need S3. Need secrets manager. We'll talk about all of these things and what this means. And lastly, we need the AWS SDK. My voice just cracked really badly. Great. Oh, and just for fun, just something, I do want to use prettier. 2.0.5. Oops. Okay. So there's actually no difference between dev dependencies and dependencies. It's just for your personal, it's just for your management. Like, okay, this code actually doesn't matter at all. Okay, so So now that you added all this to your package.json, you exit out and do npm install. And npm install looks for a package.json file, and it just installs all the dependencies that you added to it. Do I normally do all this in Windows? Well, I do work on a MacBook, but I don't dual boot Linux, so I just use this. This is Windows subsystem for Linux, basically. So this is not actually Windows. This is running Linux, technically. Did I forget the comma? No. What comma did I forget? Okay. So now, 1 second. So now I can actually do the thing, right? So we're gonna talk about CDK for a little bit. A stack is a AWS CloudFormation thing. A stack is basically a set of resources, of AWS resources that are grouped together that are deployed as a single file, basically. So in a stack, you just define all the things that you want. Do you think it's ever worth dual booting now that we have WSL? Yes, actually, because WSL is kind of shit sometimes, and like Windows Terminal is actual like total dog shit. I just do this for convenience, but if I really cared, I would actually dual boot Linux. Can you show me your vimrc? It's on GitHub. So the first thing that we need to do is import star as code pipeline from AWS CDK AWS code pipeline. And also, just as an aside, I hope that most people here do have some programming experience, because I'm not gonna really like go over a lot of like basic programming stuff. Like I hope you know what an import is. I hope you know what a class is. Things like that. New code pipeline dot. Okay. Give me one. So now, oops. AWS CDK code pipeline. So, if you don't know what you're doing, and I never know what I'm doing, you just Google search it, right? And this will come up. Like, okay, cool. To construct an empty pipeline, you do new code pipeline dot pipeline. Great. And this, you need a scope. If you have a stack, if you're inside a stack, is almost always this, just the stack. I need to give it a name, so we call it HealthyGamer Workshop Pipeline. And we got to give it some properties. So we need to give it some properties. Pipeline props. Okay. What do pipeline props look like? Oops. So apparently I can give a pipeline a name. I don't care, because I don't care about my resources. Resources are cattle. They're not pets. You don't need to give them names, usually. Okay, so let's take a look at the pipeline thing. And what goes inside my properties? Okay. So I can give it a name. I need to say, do I want to restart execution on update? This is something that I do want. Restart execution on update true. Stages. I have to give it some stages. Stages. This could be a long time. So let's just factor this out to a method. Render pipeline stages. You don't have anything, that's fine. I don't care. So private render pipeline stages equals, takes no inputs, returns code pipeline dot stage props. Code pipeline dot stage props. Return new code pipeline dot. Wait, give me 1 second. Return. Okay, no, sorry. Return. It's an array, so I don't need a new actually. for now. So what goes inside a stage prop? I need a stage name and I need an action. Cool. Stage name. The first stage in your pipeline is always your source repository. So we'll call this GitHub source or whatever, doesn't matter. And as an aside, if you have a question mark at the end of your thing, this means that it's optional. If it doesn't have a question mark, it means it's required. So I need to have a stage name. And I guess a stage doesn't need to have actions. It's kind of weird to me. So I don't know. Actions. So what do actions look like? Okay, there's a whole bunch of action things. I want a GitHub source action. Cool. So GitHub source action. Source that is provided by a GitHub repository. Great. New. And this GitHub source action is in the code pipelines module. So code pipeline actions module. Code pipeline actions from actions. So new code pipeline actions dot GitHub source action. Great. Now what properties does it? Now what properties do I need? Okay. I need an action name. All right, fine. I need an action name. We'll just call it GitHub source again. Doesn't matter. I need an OAuth token. We'll talk about that. OAuth token. Just give it some random thing right now. Output. What is an output? An output is an artifact, and okay, I don't actually need to do anything. I just need to call it an output. So const. What do we call this? Source output, I guess, equals new. This is a code pipeline artifact, so new code pipeline dot artifact. Great. And I just give it the output. That's fine. I need an owner, so who owns the repo, and that's me. I need the repo name. The repo name is HealthyGamer Workshop. The branch is optional. I'm not exactly sure why the branch would be optional, but we should just say that it's the master branch. Cool. Okay. So, what is an OAuth token? An OAuth token is like a password that services give you that you can share with other people, with other applications, so that they can act on your stuff, basically. GitHub exposes this sorts of thing as a personal access token. So if you Google search GitHub, you'll come across this page. Configure your code pipeline to use a personal access token for GitHub. Okay, cool. And I don't know, just follow things and you create a personal access token, basically. When you create a personal access token, you'll come to this page, basically. And I can show you this page because, oh shit. Fuck. I can't show you that page, God. What the hell is this? What the hell? Oh, there it is. Why is it hidden? Okay, great. Great, so you click the token and they're not good. You only have one opportunity to see your token. They're not going to give it to you, so you have to store it somewhere, save. Okay. And you give it the permissions that AWS asks you to give it. So they want this one and they want this one, I'm pretty sure. Repo and admin repo. And I do some other things too, so I just use it. So I just give some other things. Cool. So now, here's the thing, right? I'm not going to name names, but in the HealthyGamer Discord, in like the debug sections, I've seen some people who paste their code asking for help, and they will have their API keys or their API tokens inside the code, and I can see it. That is a very, 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 very bad thing to do. You never, ever, 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 ever want to store your tokens inside your code, okay? Treat them like your passwords. Never put them inside your code. If you do, and you put your code on GitHub, it will be found, it will be stolen, you're going to have to pay for it. So don't do it, okay? You need to use a secrets manager to manage your tokens, okay? These are things that they store your passwords remotely, and that you can interact with it via another API. So at AWS has one. It's called AWS Secrets Manager. You know, pretty self-explanatory name, and you create a personal access token for it. And you know, and I've added my personal access token to GitHub. And it's not hard. You know, oh, what the fuck? Okay, give me 1 second. What the hell is that? Do I need to refresh? Yeah, I need to log back in. Okay. So you know, I'm logged in now. Yeah, never check in credentials, ever. Anything that you use to interact with anything. It could be a password. It could be an API token. It could be like, don't ever do it. Okay, you need to use a secrets manager. It doesn't have to be AWS Secrets Manager, but although that's what I'm going to use. Okay, and for us, you know, you just do other type of secrets, and your key could be whatever you want. I believe mine is OAuth or something. I don't remember. And this is your password. This is your actual secret. Like blah blah blah. Who cares? It's gonna be some random letter. You give it a name. You don't need a description. Whatever. Configure rotation. For secrets that are managed by AWS, for like keys, you can do enable automatic rotation. However, if it's for like a GitHub OAuth token, GitHub manages that. So you disable automatic rotation, and then you create it. So I've done this, and I can click into it. As long as I don't click retrieve secret value in front of you people, it's okay. Right? So, you know, I have a thing. So now we have to interact. So now I have to fetch my secret from GitHub and put it on, and give it to the CDK, basically. So I have to write some code to do that. Let's see, what's it called? Bin cdk.ts. Been going for almost an hour now, so pretty okay. We got like another 30 minutes to maybe another hour to go. So first things first, import star as secrets manager from AWS SDK clients secrets manager. Did I spell that right? Manager. Okay. Notice that it's SDK this time. It's SDK. It's not CDK. These things are different. Okay. The SDK enables you to talk to AWS stuff like Secrets Manager. The CDK is used to build templates. It's infrastructure as code. They're different. So first thing that we're going to do is just define a function here. Function get secret detail. Describe. I'll call it describe secret because I'm pretty sure that's what the thing is. I need a secret ID, and that's a string, and this returns a secrets manager. I believe it's a describe secret response. Actually, it's not this. It's fs. It's actually a promise, and this has to be async. Bam. Okay. So async. What is async? Asynchronous stands for asynchronous. Okay. An asynchronous function doesn't return a thing. Doesn't return what you want. It returns a promise. And a promise is just that. It's like it's saying the language is saying, I don't have what you want right this second, but I will have it in a little bit. So I'll give you a promise for it. It's an IOU. I owe you this secrets manager describe secret response. Okay. And when you see a promise, the language runtimes do a lot of things in the backend to see oh, okay, what else can I do while I'm waiting for this promise? And then when the promise comes in, okay, we'll go back to doing this now. Const s secrets. And when you're using the AWS SDK, there's just some things that you gotta do. Secrets, it's new secrets manager. Let's see. Const request secrets manager dot describe. It's not a response this time. We need a request, and this one needs a secret ID, and we'll give it secret ID. I think that's what it looks like. What's the problem? Did you mean to write secret ID? Thank you. I meant to capitalize it. Great. And now return secrets dot describe secret request dot promise. Great. Any questions? Chat is not. Is my chat frozen? Okay, no, it's not frozen. I don't care. Great. So let's go through this one more time again. Secrets Manager is an AWS service. It's AWS Secrets Manager, right? This says I want to be able to talk to AWS Secrets Manager, and I want to and the API function that I want to call is describe secret. So if I want to see this page, I want to describe secret, and the request structure for this looks like secret ID. And I just give it secret ID from the function. And again, this is a network call. Okay, this is not something that you read a file or whatever, even though files are also promises in Node.js. This is a network call. You don't know how long it's going to take. The runtime doesn't know how long it's going to take. You might have a lot of things that you wanted to be doing, so it's okay, I'll just fire this network request, and then when it comes back, and I'll do some other work, and then when it comes back, I'll come back to whatever I want. That's basically async await. That's basically async and what promise is. Does that make sense? I think it makes sense. Okay, so now we got to actually use it. So if you want to wait for a promise, if you want to consume a promise, you have to call this function with await. So await describes secrets. And then my secret ID is called GitHub Personal Access Token. So I'll call it GitHub Personal Access Token. Great. Const secret. We'll call it GitHub secret, I guess. Equals await secret. And now this response also has a different structure. So I specifically want to pass in this into my stack. So what is this? What is an AR? Okay, let's scroll this up. What is an ARN? Okay. An ARN stands for Amazon Resource Name. Okay, it's basically a way that Amazon has for managing everybody's resources. It always starts with ARN, a colon, And then AWS, sometimes it's going to change, but for most people it's not going to change. It's going to be AWS. It has another colon. It has the name of the service. So the service is Secrets Manager. So the service name is Secrets Manager. It has another colon. It has the region that you're in. So for us, my region is North Virginia, US East 1. So it's in US East 1, North Virginia. Another colon. It has your account ID. And by the way, account IDs in AWS are not secret. Like, it's completely fine. Like, AWS themselves publishes like hundreds and dozens of their own account IDs for you to do things with them. And it's just okay. It has another colon. And then finally, it has the type of resource it is. So, and this is a secret. It's a secret. And then this can have a colon, or sometimes, or like for different services, it's not a colon, it's a backslash, it's a slash. Like, it's completely random. And then it has some identifier for your actual resource. That's what an ARN is. Amazon resource name. We usually just call it ARN. Everybody inside Amazon calls it an ARN. So, CDK stack. I want to pass in the ARN of my GitHub secret. So I do secret ID is GitHub secret dot ARN as string. A couple of things here. So like this GitHub secret has some stuff inside it. So GitHub secret, oops. It has all these things. It has all these properties inside it. The only one that I really care about this time is the ARN. Okay. And because if you see that there's a question mark after it, that means it could exist. Now, in practice, it's always going to exist, right? But this is just AWS, what's the phrase? They're just making sure that maybe if it does, maybe sometimes it doesn't, like just in case. That's a question mark. So we have to say specifically, like, okay, this is a string. This will always exist. It's a string. And now, there's an error, and this error says, argument of type secret ID is not assignable to parameter of type stack props. Object literal may only specify known properties, and secret ID does not exist in type stack props. What does that mean? CDK stack. So here, inside the constructor, we give it the scope, we give it a name, and we give it some properties. And this properties is, again, optional. Make that not optional. What this is saying is that this doesn't match up with what I expect. A secret ID is not part of cdk.stackprops. So, okay, what we have to do is we got to extend stack props interface CDK stack props, which is kind of an unfortunate name, I guess. Extends cdk.stackprops. And now we just say, okay, and now we're using CDK stack. Now we're using this stack props instead of this stack props for my properties. And now I can say, okay, I have a GitHub ARN. What did I call it? I call it secret ID. That's kind of a terrible name. We'll call it secret ARN, I guess? It's not an ARN. It's not an ID, it's an ARN. So GitHub secret ARN is a string. I think that's a semicolon at the end. And now, no more error. Because what I've given it now squares with what it expects. And somebody asked the question earlier in chat, what's the difference between TypeScript and JavaScript? TypeScript lets you do this. It allows you to specify what things look like so that you never pass in more or you pass in less than what you expect. Or you pass in something completely random at all. Because if you pass in something completely random, TypeScript will tell you, hey, you've done something that I don't know what to do with it. That's an error. And there's one more error here, and we'll talk about that in a little bit. Great, so now I can use it. private props. Oops. Private props. Say CDK stack props. This dot props equal props. So now I want to use my OAuth token from my secret, and to consume it, I need to use a CDK thing. So import star as secrets manager from CDK AWS secrets manager. Again, oops. Again, this secrets manager, this secrets manager is different from this secrets manager. Okay, one is the AWS client, and the other is creates a resource or uses a resource. You've been lost for a while. Is he creating a? Well, I'm just getting started. But is there any questions about what I'm doing right now? Oops. It's fine. You're just setting up AWS, right? Yeah, I'm setting up a pipeline. I'm setting up the very foundations of the things that we need. We're not actually we're going to be using this pipeline to build out our entire infrastructure in later sessions. And feel free to at me if you have no idea what's going on. That's completely fine. Right. So now I have to consume my OAuth token. So I'll call it source auth. I don't know. Equals. So secrets manager. I want a secret. Okay, so I'll use a secret. So secret, and let's see, static from secret arn. So I can create a secret. So I can create a secret that if I have a secret that I've already created, I could just use that. So that from secret arn, and that's props dot secret arm. What do I mean by building a pipeline? If you were here for the session, for the lecture earlier, I talked about a CI/CD pipeline. Control 5. I talked about a CI/CD pipeline. It's something that consumes your code and compiles your code and allows you to let customers see your changes soon. So that's what we're doing right now. It's the very foundation of your application. Because otherwise, if you don't have one, you have to make all these manual changes and things, and it's a pain in the ass. It's a giant pain in the ass. So this is how we get started. What's the thing? From secret. What am I doing? Okay. So expected 3 arguments, but got 1. Okay, I should just take a look at this. The scope is always this. The ID is, what do we call this? I guess we'll call it GitHub secret, I guess. And the arn is this. Yeah, this dot props. Great. And now here, instead of ASDF, I can do source auth. Wait, can I? No, because I still need the token. It's missing properties from type secret value. Okay. So I need to actually get the secret value. Let's see. Secret value from JSON. Cool. So instead of this, I do dot secret value from JSON, and the parameter JSON field string. So I need to give it the key. So like when we were creating this, you have to give it a key and then their value. So it's to look at what value it is, and I believe mine is called OAuth. OAuth. That's it. And now we're happy. And now we have no errors. Except for this thing. What is this? What is this error? Top level await expressions are only allowed when the module option is set to ES next or system. And the blah 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 blah. Basically saying that you can't use await unless you wrap it inside a function or a class or something. That's what it's saying. And that's so that, like that's like the only thing that you can do is you just wrap everything inside a function. Async function. Oops, undo. Cool. So like, again here, we're defining another asynchronous function, but instead these last two pairs of parentheses says we want to invoke it immediately. We want to run this function, like as soon as we've created this function, just run it. And this is just how you do it. This is just how you wrap an await call inside a function, basically. It's just something, it's just a JavaScript thing that you need to do. And this works. You will notice, however, that there's actually like a couple different ways of defining functions inside JavaScript. First of all, you have this, and if we give it a name, this function doesn't have a name. This is called an anonymous function because it doesn't have a name, and you could do that. Here's another different way of defining a function. This is kind of a different syntax, but it's just a function that you can do. And I generally prefer this one, but it's called the fat arrow function because you have a fat arrow inside it. I'm not familiar with any type languages. Could you go through what functions, classes you're defining and what they return? Well, see, that's the great thing about type languages is that I don't need to define it. You can just look at the function definition. So like, see, in this render pipeline stages, this is a function. It takes no inputs, and this colon says it returns an array of stage props, or a list of stage props. If we go back to this one, this is a function. It takes one input, it's called secret ID, and that secret ID is a string, and it returns a promise to a described secret response. This function takes no inputs and has no outputs. Cool. Great. So now we actually need to do one more thing, and this is something that I found out later, is that pipelines need to have at least 2 stages, otherwise your thing won't compile. And that's a little annoying. So I have to give it a second stage. Great, so we go back to this. And in my opinion, the thing that you should have after your source is something called a self-mutating step. And so your pipeline deploys code, but it also deploys the code that defines itself, right? We want the pipeline to be able to change itself so that if we ever add anything to the pipeline can just change itself, and then we could add stages, and then everything just flows through again. That's what a self-mutating step is. Actions. And for this one, I'm going to add a new code pipeline actions.CodeBuild action. And this one should have action name, we'll call it self-mutate. Input, wait, I should show you this. I should show this. Stage props, action, the one that we want here is a code build action. Because what we want this step to do is we want to take our source code, we want to compile it, and then we want to use the CDK code that we have here to change itself. And none of these really apply except for code build action. So code build action props. What do we need for a code build action props? We need an input, this artifact. So for the input, we'll just use the output. So source output. Let's see. Outputs. So this thing should have another output too because it's a pipeline. This step should have steps after it that, you know, consume whatever we want. And I guess, I don't know, for now we'll just use source output also. Like this thing doesn't, for now we'll just say that it doesn't actually produce anything. It's fine. It doesn't produce anything new. And the last thing we need is a project. Okay, what's a project? Implemented by pipeline project. Okay, pipeline project. It's a code build thing. So, okay, we'll just call it project this.render self mutate project. What is the problem here? Only, did you mean to say output? Okay, outputs. And I guess outputs, so it should be an array then. Again, the nice thing about type languages is like it just tells me, hey, this thing doesn't match what I want it to. So it just tells you, hey, it needs to be called, instead of output, it should be called outputs, and it should be an array. Great. So now we got to define private render self mutate project. This takes no inputs and returns a code build pipeline project. Cool. Code build dot pipeline project. Oh, I need to actually import it. Import star as code build from. Code build. Now it'll show up. What do I want? Okay, so what does this look like? It needs props. Return new code build dot pipeline project. What does this need? It needs the scope, it needs an ID, and it has some properties. Cool. The scope is always this. This one we'll call it, I don't know, self mutate project. I don't know. What props does it need? Okay. Is anything required? Nothing is required for some weird reason. It's a little jank, but okay. But we need a build spec, build specification, build spec. Let's see. What does this look like? From object, so it doesn't, so this thing actually doesn't need anything. It's just a random object. All right, fine. I gotta cheat a little bit. Code build dot build spec dot from object. So if we look up AWS code build spec, build specification reference for code build. Jump to build spec syntax. Okay, so we need to give something like this to here. And by the way, this is what YAML looks like. If you're here for my rant on YAML, this is what YAML looks like. YAML is fucking shit. I hate YAML. Okay, what do we need? We need to give it a version, so version 0.2. I guess that's just like a magic number, version 0.2. And we need to give it some action. We have to give it some commands, like things that we want it to do. Phases. So here's the thing about a continuous integration step, is that it really is just a server that you tell things that you tell it to do. It's just a server that takes in some commands and then it just builds your thing. So most CI solutions, it just kind of looks like this. It just says, okay, in the install step, what commands do I run? In the build step, what commands do I run? After I build, do I do anything else? Okay. In our install step, install commands. And these commands are going to be Linux commands, like in the terminal commands that I showed you a little bit earlier. A lot earlier, holy shit, it's been an hour and a half already. So the input, the source input for this is going to be this entire directory. So if you go here, it'll have license and it'll have a CDK folder. And we want it to operate only on the CDK folder. So the first thing that we ask it to do is CDK. Right. And the second thing, and then the next thing is npm install. And like, again, it needs to install all the dependencies that we added here to be able to compile our code. So it has to install it. And that's it. And now for the actual build step, build. I believe it's just npm commands, should be just npm run build. Cool. Does it need any outputs? No, it doesn't need any outputs at all. And let's see, where was it? It was here. Okay. Environment. What build environment do I want to use? What does a build environment look like? Build environment. Build environment is just an image. What's an image? I build image. Default compute type. This looks a little complicated. Can I just use it? Obtainable from, okay, so I could just use, they have some pre-built ones for me automatically. So CodeBuild dot Linux build image dot, and judging from this, I guess we'll just use standard. Oops, standard 4.0, and that's it. Is that it? No. What am I getting wrong? There's no properties in common with type build environment. Okay, because build environment is another object. And it needs build image. Cool. What is pre-build even used for? I have no idea. Like these designations are arbitrary. You could run your install step inside your build step if you wanted. You could just run everything inside post build if you wanted. Doesn't really make a difference. Okay. There is one last thing that I need to do, and that is that means I can't return const. That means I can't return this. I just have to save it to a variable, which is called project. Is I need to give it return project. I need to give it permissions. What does that mean? Here, we're saying that if you want to build this CDK application, you need to be able to describe my secret. AWS, by default, locks down permissions so that if you don't specify exactly what you need, it won't let you do it. So for this project, I need to say that you are allowed to describe my secret. And to do that, AWS's permissions thing, permissions service is called IAM, Identity and Access Management. I don't want to say every AWS resource, but basically, all AWS resources that do something, that take other resources. For example, here, I'm giving it my GitHub stuff, and it's producing some other stuff. Needs to always has what's called a role, and a role is just a collection of resources. I mean, a collection of permissions. So if we look at these workshop testing ones that I have, that I've created for testing my stack, it gives it some permissions. And a permission looks like this. If you remember the first session, I pasted in some magic thing to make my S3 go, to make the bucket public. And this is basically the same thing for different services. So for example, this role is given this CodeBuild, or is given these CodeBuild permissions. So that's what I need to do here in my project, is I need to give this CodeBuild project permissions to look at my secret. And to do that, we create what's called a policy. Policy, there's new. I need to import star as IAM from AWS CDK AWS IAM. Bam. Create a policy statement. This is a policy statement. Okay, this in general is a policy. A policy is a collection of resources, a collection of permissions, and a policy has however many statements that you want that allows or denies certain actions. So like CDK by default generates lots of these permissions for you, but it doesn't give you everything. So like if you need something outside of the standard, you have to do it explicitly by adding a new policy to the statement that it gives. Secret policy dot add action secrets manager describe secret. Secret policy dot add resources. This dot props dot GitHub secret arn. Okay, so here, add action. This action is now secret manager dot describe secret. Resource is the secret. Is the secret arn is the one that I passed in. It's this one. And this is the only one that I want, so I'm locking it down so that the only secret that you can describe is this one. Now finally, project dot, how do I add it to my project? Pipeline project props, not this one. And project here. Add to role policy. Okay, like I said, these things come, like CDK builds a role policy for you, but you could add things to it if you wanted to. Add to role policy, secret policy. And now I'm done. Oh wait, it's not npm run build, is it? It's actually, sorry, I believe it's CDK deploy. And that's actually everything. Now let's actually try and do this. CDK. So the first thing we'll do is CDK. I believe it's build. Oh, CDK synth. It's CDK synth. And this will just run for a few minutes. Are there any questions while this takes like 2 minutes to run? Not really. Okay. Is everything... Oh, what the heck? Both actions are producing an artifact, and every artifact can only be produced once. Oh, I didn't actually know this was an issue. Okay, so we should just change that. CDK stack. We'll just give it a dummy output then. Const self mutate output equals new code pipeline.artifact. We just say instead of source output, we call it self mutate output. So are the YAML parameters like creating objects and passing parameters for construction? Are you talking about the build spec? Are we talking about this? Again, we'll try CDK sim. Yeah, basically what that is. So like for your environment, you can set like if you want to store some like aliases in here, you can probably do that. So like in the install phase, you give it whatever commands that you want. And yeah, CodeBuild lets you specify like, okay, after you run your build, you know, you could like add artifacts, your build artifacts. The things that you created, you could pass them along to the next stage of your pipeline. Okay, cool. So it's synced successfully. Let's take a look, see. So vim cdk.out cdk stack.template.json. Okay. This thing is 682 lines long. 682 lines long. This like I had that rant about I hate YAML and JSON. Imagine writing all this crap by hand. What the fuck? Like you lose your mind doing it. It's awful, and I don't even know how many things that we have, but we do not have a lot of things. Okay, like I've only added like a couple of things to it, and it's almost 700 lines long. Okay, some of like at Amazon some of the templates that we use are like thousands, like 10,000 lines. It's insanity. It's awful. Okay. Yeah, abstraction. Great. So we have this template. I want to deploy it now. And to do that, it's CDK deploy. Go. And this will take like 10 minutes, probably. So we'll just watch it run. By the way, I have to approve some things. By the way, using AWS CloudFormation is free. You don't get charged for using it. Yes, I want to deploy. Code pipeline is free for the first pipeline that you have. I think every pipeline after that costs like $1 a month. And AWS CodeBuild gives you, I believe, 100 free minutes of build. And after that, it costs like a cent for a minute, something like that. All right, cool. So let's refresh this. CDK stack. So CDK stack. This is what I'm building right now. CDK stack. You see when I type CDK deploy, it's going. Create in progress. And now it's creating a bunch of IAM roles for me. I refresh. It's creating a bunch of IAM roles. YAML can be auto-generated as well. That's what CDK is for, man. But like, it's very difficult to actually do that for AWS because there's just so many different types of resources that, you know, your things are never in sync. One of the biggest problems of using YAML or JSON for your templates is that there's no way to validate that it works unless you actually just go and try it. How many resources are we up to? We're only up to 5 resources right now, and there's probably more. It's probably like closer to 10, but. Terraform is alternative? Yes, sure. But again, Terraform, there's no way to validate that your thing works besides actually, you know, trying it, right? I'm pretty sure. Same thing, no? Yeah. And besides, CDK can actually be used to generate Terraform. Oh, another thing, like stupid KM, like encryption keys take like 2 minutes to create for some weird ass reason. Like, I don't understand. I don't know why they take so long to make. I mean, it's an encryption thing, so I guess they have to be like, you know, very secure about it. But still, it's really annoying. Like this thing, this KMS key will take the longest out of any other resource. This UI is just so bad. Like it just like randomly like shifts by itself. I go back, okay, now it's wrapped. I go to a different line, okay, and now it's not, and now it's unwrapped. I'm like, what the hell is this crap? Come on, guys. This bug has existed for like 2 years. It's so annoying. It just squashes everything else because your logical IDs get so long. Cool. The key completed. You can never be sure that it will generate valid infrastructure, but you can create modules and reuse them to increase your chances. Well, it's the same thing with CDK, right? CDK, CloudFormation. CloudFormation allows you to. One of the things that you can do with CloudFormation is create small templates and call your templates from inside other templates. But again, the only way to make sure like that it works is just try it. Cool. Now we're done. Now we go to code pipeline. We have a new pipeline. HealthyGamer Workshop pipeline. Let's see the details. I hope this works because it will be very. I will be very sad if it doesn't work on the first try. Command CDK can't CD to CDK. Oh boy. What? Oh, I know why. Okay, I know why. I know why this is happening. This is happening because GitHub source initial commit. Initial commit. What is in the initial commit? The only thing inside my initial commit is my license. I didn't commit this yet. So let's do that, shall we? Git status. What's inside my git status? Oops. Git status. And it's everything inside CDK. All right. Well, I guess we'll just add everything. We'll see what happens. Git status again. Now will finally tell me what code that I have. Okay. So everything looks okay, I suppose. So git diff staged. Okay. So here's the thing. When you have code, before you want to commit it, you have to stage it. And you do that by doing the git add command. Git add dot just says add everything. I don't care. Okay, so now if we do git and git diff by default will only show you changes for your changes that were not added yet. If you want to see changes that you've added, you have to do -- staged. Okay, and this opens a terminal command called less. If you want to navigate, you can use up and down. You can also use J to go down and K to go up. You can do F to move forward by a page. And you can press B to go back. You can press capital G to go up, to go down to the very bottom. And you can press GG, good game, to go up to the very top. All right, this looks okay. This looks okay. let's see, this code, it looks okay. CDK, that looks okay, that looks okay. CDK stack, this is all the code that I've just written. That looks, I mean, it's just what I've written. Oh no, it's package log.json. I told you you don't want to look at this. Would you like to see why I told you you shouldn't look at this? Let's go. Let's count how many pages are in package log.json, all right? So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80. Okay, I'm fucking done. I don't know how long this is, okay? Don't look inside this. Don't look inside this. And these are pages, okay? This is like, if I scroll up completely, that's a brand new page, okay? Don't look inside it. Don't look inside it. Great, and everything looks fine. So I've added everything. Git status again. Just now git commit. Git commit by itself will open your default terminal text editor, and for me that's Vim. So now I get to finally show what Vim looks like. Okay. So when you use Vim, you can use the arrow keys to move around, but it's not really recommended. But if you're typing in Vim, you will notice that, what the hell? That's not what. You will notice that, I've actually changed it. Okay, you will notice, okay, I'm pressing F right now. I'm pressing F right now. You can see here, I'm pressing F. Nothing's happening. Nothing's happening. Why is nothing happening? Is because Vim is what's called a modal editor. Vim operates on modes, and the mode that I'm in right now is the normal mode. Okay? When you're inside normal mode, you can't well, okay, so when you're in normal mode, what you can do is you can move around and you can operate on text. You can like jump around, okay, you can like delete things, you can like undo things, but you can't type. And the way you type is you press I, and when you press I, you go from normal to insert mode, and now I can start typing things. Okay? And then to go back from insert mode to normal mode, you press escape by default, and now I'm back in normal mode. So, let's see. This commit message. Now I need to write a commit message. Please enter the commit message for your changes. Okay, real initial commit. Create CI CD pipeline with integration to GitHub. Okay, now I press escape. I'm back in normal mode. Now here's the meme. The meme is, how do you, if you put a newcomer in front of Vim and ask them, how do you escape Vim? Okay, if someone, how do you escape? How do you exit Vim? I'm here to show you how. From normal mode, you press semicolon, and that brings you to command mode. Okay, that brings you to command mode. Command mode lets you operate on on every file that's open right now. So if I press Command W, that writes the file. It means it saves the file. Okay, and now I can press Command Q, and this will exit. If you want to combine them, you can do WQ for save and quit. WQ, save and quit. And now, if I type git log, I see two commits. I see my initial commit with the license, and now I see my second commit that I've actually done. And now we do git push. Bam. Okay, no errors. So now if we go back to HealthyGamer Workshop, we see that my CDK directory is here, and it has all the code that I've added. It has my CDK stack, and it has all this crap that I've added. So now we go back to, not this one, to our code pipeline. It's with the integration to GitHub, it'll automatically see that, okay, you've pushed a new commit. So we'll just take this commit and we'll use it. We'll take a look inside this build. Okay, and now when it runs cd CDK, it succeeds because, you know, there is a CDK directory now. And it's running npm install. Great. It failed. Oh God, why did it fail? Reason, let's see, running CDK not found. Okay. CDK not found. Well, that's new. That's never happened to me before. What the hell? Oh boy, we got some live debugging going on now. CDK not found. Yep, debugging stream time. Oops. CD CDK bin package.json. Well, it's there, so it should have installed. Okay. Oh. Okay, I know why. So yeah, it is an environment thing, and it's because like when you install CDK, if you don't install CDK globally, it's not added to your path. Basically, it means that it can't find the CDK thing even though it's installed. So what we have to do is I have to change this to vim lib CDK stack. I have to change this to npm run CDK deploy. Yep, somebody got it right in chat. Somebody got it right. npm run CDK deploy. So here's the thing, right? Because my self mutate step is not working, I have to update it manually. So we have to run CDK deploy manually. So instead, now we do npm run CDK deploy. And this is going to take another, I don't know how many long. It's going to take shorter than the original one because we're probably not updating the stupid key. So, are there any questions about what I'm doing right now? Anybody confused? Anybody doesn't understand? Anybody hates programming? Take a look at here. It's creating a change set. Change set is just a diff between your current template and whatever you want to change it to. So now it's executing the thing. Update in progress. Does everybody understand like what the issue was with why you couldn't find CDK? You don't think I was ready for the stream? I might be going a little fast, but if you do have any like issues with it, and this bot is going to be uploaded, right? So if you have any questions, like you can feel free to ask in the Discord. Think I'll have to learn some things and come back to it. What sort of things? Please just tell me. We have time. Okay, great. It's done. Yeah, you can watch session 1 too. So now, if I update, this is still failed, but if we go to CodeBuild, this project, build details, and now let's take a look-see, and it's been updated to npm run CDK deploy. We can retry this. Yeah, if you have any, if you don't know something, just ask in chat. It's fine. Hurry up. Why does it take so long? Why is there no way to refresh the thing right here? Come on. I don't want to have to refresh the entire page. This is going to take like another minute. The neighborhood kids are beating a tree outside. Oh my god. What the hell is this? User arn AWS STS assumed role is not authorized to perform describe stacks on. Okay. So I made some changes to when I was testing this to something else, and I guess I have to change it now. Here's the problem, right? I mentioned earlier that CodeBuild by default doesn't give you any permissions to do anything, right? They lock it down. The only permission that I've given it so far is to describe a secret. What this is saying is that CodeBuild needs more permissions to do something. It's not authorized to perform CloudFormation describe stacks. So I was hoping, so here's a little cheat that we're going to do, and I'll fix it. Vim lib CICD stack, CDK stack. Instead of secrets manager describe secret, I'm just going to do something very bad. This is something very bad. Const very bad policy equals new IAM dot policy statement. Very bad policy dot add actions star. Very bad policy dot add resources star. Oops. Project dot add to role policy very bad policy. Okay, star means everything. So add actions, every action on any resource. This is bad. I don't think I really need to explain why this is bad. Being able to do anything is too permissive. This thing does not need this many permissions, but we'll fix it. As you know, we'll fix it. Again, because my code build stage is broken, I have to deploy manually. Star, Monka S, exactly right. If you see star, you have to ask, like, what the fuck are you doing? Very rarely do you need star. There's actually one place where you do need star, and we'll get to it next time. There's actually two places. So I suppose a question that I should probably have answered earlier is that how come I don't need permissions? How come I don't get this error? It's not authorized to perform CloudFormation describe stacks. And the answer is when you use the AWS CLI client, which I think I closed the tab. Install AWS CLI. One of the things you do after you install the AWS CLI client is you create credentials for yourself. Okay. And if you do AWS config, if you type AWS configure, you know, it'll tell you, hey, I need some credentials. Okay. And you do that the same way as a role, except instead of a role, you create a user. And that's what the user is. Like, here's my user. And these are the policies that I have attached. I've given myself admin, which, like we said, is very bad. I probably shouldn't have admin, but because I'm the only person that uses this, fine, whatever, I can give myself admin. If you work at a company, people should not have admin access. Very rarely. Okay, giving yourself admin administrator access is a break glass in case of emergency sort of thing only. This is bad. I recognize that it's bad, but you know, there's no like real cost to me, so whatever. If you're doing this on AWS, you know, you might consider doing this, and if it's just for yourself, it's fine. It's for your business, don't do this. Okay, great. So now let's take a look at this thing again. Build details. Service role. What's inside the service role? Now inside this, it has a bunch of random crap. And where is my star star? Here it is. Star star. Now, if I rerun this, it won't fail with that permissions error. It might fail with another error, and we'll see. Well, that's the fun of live debugging. Oops. Details. Star star. Yeah. Okay, so the two places that are acceptable for doing star star is actually, you know, break glass in case of emergency sorts of situations where, you know, you just need to do something, you need to fix it right now. The second is actually using it with CloudFormation, because CloudFormation also needs a role, needs to consume a role to be able to do things, right? You need to give CloudFormation permissions to build all these resources. And sometimes you need to give it permission to delete these resources. Now, here's the thing. You could look through your template and you can see, okay, I create a bucket, I create a key, I create blah, 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 blah. And you could enumerate all those. But if you ever need to change it, man, that's a pain in the ass. So like in AWS itself, when we use CloudFormation, we actually do give CloudFormation star star permissions. I'm not saying it's good, I'm just saying it's what we do. Did all that make sense? I don't even know how many people are in chat right now. Okay, great. And deploy is now running. Oh God, why did it fail now? Huh? CDK is not authorized to perform describe stack on resource. But I gave you star star. I gave it star star. Why is it failing? Okay. Okay, I didn't want to do this, but I guess I don't have a choice. Assumed role is not authorized to perform CloudFormation describes stack on resource. What is this called? Blah blah blah. So CDK stacks 7ANK0. It's you. That's weird. Didn't I give it star star? Oh. Ha ha ha. I know why. It's because we didn't commit this. It's because this is trying to run an outdated source right now. So I have to tell it to actually start deploying this. Git commit, git add, start, git commit. Do very bad thing. Git push. Some live debugging for you right there. Now this will update again. There it is. Do very bad thing. And now very bad thing should be okay. Wait a minute. Did it roll it back? I might have gotten into a weird state. Interesting. So wait, it completed the deployment and then it failed afterwards. That's kind of weird. So I guess this might fail again. Man, I really should audit it. Oh, yep, there it is. Yeah, it's in, yeah, again, look, it failed for the same reason as last time. It can't find CDK because it's trying to use a bad deployment, because it's trying to do a bad thing. So CDK deploy one more time, just to get into a good, I need to get into a good state so that I could stop running CDK deploy manually and I could just do it. God. It's been 2 hours. Yes, gotta approve it again. But like, this is what I mean when I say that, you know, CloudFormation, there's no way to like validate what you're doing is right until you try it. And like, if you like mess up, and this is also why like you shouldn't let stupid meatbags do it, because they'll mess up the order of which you're doing things. You know, you get your CI/CD pipeline in a good state, and then you just hands off on everything else afterwards. I am, you know, demonstrating exactly why. Yep. It's okay. Again, while this is running, any questions at all? Okay, it's done. Do very bad thing is the source. We'll retry it. I'll retry it. Six builds, just to get this to a good state. But this should work. This should work. Install CDK deploy. Creating change set. Create my change set. Please don't fail. I created a change set. I didn't see one. Come on. Maybe it's this one, I guess. There really ought to be a way to update this stupid log without refreshing the page. Okay. Oh, thank God it succeeded. Oh, goody. I'm not a total failure. All right. Now, just to show you guys that this actually does work, let's just do something really, silly, something completely meaningless. Just change this. Git diff. Hello world. Git commit am. Do something else. Okay. Git commit a adds your changes. M stands for message, and you could add a message to your commit. One thing about A is that if you create a new file, git commit -a will not track it. So you have to do git add that file manually. So again, if we look at git log, do something else. Do something else. Git show. See that? And just to show that my pipeline is actually working, let's just watch it go. This will take another couple minutes. Oh no, oh God, really? Okay. God damn it. Always with the blockers. Web CDK. Okay. So you saw that sometimes when I run CDK deploy, it asks me, "Hey, do you want to make sure that you really want to do this?" And so we gotta turn that off. I gotta turn that off. God. One more thing. Approval. Is it no require approval? AWS CDK deploy. Require approval. Yep, one more thing. I hope to God this is the last thing. Require. Yes, this is what it typically looks like. All right, this is what it looks like. You do something and you're just like, God, it doesn't work. You're just like, God, why can't it just work? Okay, so it's not no require approval. It's require approval. Never. Just shut up. Don't talk back to me. Do what I tell you to. NPM. Okay, oh, there's one more thing I want to do. This is what it looks like. This is every day at work, man. Self mutate. Okay, CDK deploy. This is what it looks like. This is what engineering looks like. You just hold your head in your hands, just like, why the fuck is it not working? And then you figure out why it's not working, and then you find it, and then it's just one more fucking thing. No matter how good, yeah, gotta waste 20 commits and builds for it. That's exactly right. That's exactly right. And you would have thought that, hey, you know, I have a testing pipeline. Why didn't he just copy the testing pipeline exactly? Well, the answer is I almost did, but I wanted to make some changes at the last second that I didn't validate. Stick with your fucking scripts. Stick with your scripts. But now hopefully you can see, you know, why. We'll see. Which, by the way, code commits. Is it this way? How do I see the commit? Okay, I'll just use this. No? Okay, it's done. I can never remember how to look at the commit history in GitHub. Is it this way? Yes, it is. Oh no, it's not. God damn it. I don't use GitHub a lot, and I can never remember exactly how to do this. Click at the last commit message. Is it this? Master? They really ought to make this more intuitive. Like, I don't know. Am I just stupid? I don't know. Anyways. Okay. Now do vim lib. Shit. Foreground. Now change spec. Take a look at this. Let's take a look. See details. Okay, require approval never. Great. Just to show that it's actually working. Please God, hopefully it works. Please God, let this work. Git diff. Git commit am. Please God, let this work. Git push. By the way, git log. You should make your commit messages, you know, they should be informative. Please God, let this work is a terrible, terrible commit message. Do as I say. Please don't do as I do. Please do not name your commits. Please God, let this work. It's a lawnmower. I believe. I don't know. I live in kind of a bad-ish neighborhood. Add stuff and fix things. Yeah. Do as I say, not as I do. Add stuff and fix things. Exactly. Please God, let this work. But you know, these are the emotions that you feel when you're writing code, and you're just like, you just hope to a higher power that what you're doing is not what you just hope that what you're doing is gonna work. And if it does, then you just like, you don't thank God if it works, you thank yourself. Because when you fix something that doesn't work, you feel like the greatest programmer. Until you get to the next thing, you're just like, please God, let this work. That's software engineering for you. You have crazy imposter syndrome? Oh, man, yeah, it happens. It happens to all of us. It happens to me. Please, God, let this work. Update complete. Update complete. Clean up in progress. Now, if we go back to this, if I refresh, it changed to please, God, let this work. So I did not do deploy manually. This thing did, and thank God it worked. Cool. So that was 2 and almost a half hour. And I am now finally finished with session 2. Next time, we'll take the stupid pipeline that took me an hour and a half to build, and we'll actually use it, and we'll use it to create an API. I'll talk about a distributed system, like distributed systems, how they work, talk about, you know, how their basic generic layouts, talk a little about using databases. And for once, we'll exercise actual creativity because, you know, everything that I did here takes no creativity at all. Everything I did here, you could just copy paste from an existing project and just reuse the exact same code. Maybe change some names around. But next time, we'll use some actual creativity. We'll actually think about what we want to do for this application. So I need to get a glass of water. My voice is really sore, but if you guys have any final questions, please feel free to ask me. Otherwise, you know, you can always DM me later. Yeah, at least it only took an hour and a half. I was tired. Okay, well, if there's no questions, then I guess we will end the stream. Thank you everybody for coming, and I'll hope to see you again next session.